Hey, this is Nate here, and in this video, it's going to be a mini tutorial just talking about depth sorting, specifically depth equals negative y. And I don't use that method. I have a little different formula that makes it a lot easier to manage, because one problem with depth equals negative y is your layers become negative. It creates unmanaged layers in the negative space. And what happens if you have something like a light engine or a camera object or whatnot, like you see, I have a light engine kind of set up here. And what happens is now your system objects like that are going to be rendered or executing after your actual world, your game world, and that can cause problems where you then have to manually move your system objects to a depth that's even lower than those. And what I do is I just normalize it to the room coordinates by taking the inverse of wherever the bottom of the entity is located, the B-box bottom. As you can see here, as I go down, everything becomes smaller, these depth values. And as you can see, if I put them close, they're still depth sorted really nice. And as I go up, they become higher because the depth is going to be a higher value. And in GameMaker, lower depth values are going to be closer to your eye, the camera, screen, however you want to say it. And it's really easy to do. It's not that complicated. And I'll draw out and explain it here in a second. So. Here in the project, though, I'll show right away the formula. It's just room height minus B-box bottom plus 100. That 100 could be whatever value you want. I'm just using it because the lighting engine in here is at depth 100, and that way everything happens before that. It could be whatever you set your system objects, however much space you kind of want to reserve for those. That would be the value here. A constant's actually fine in this case. It's not necessarily a magic number. So I'll draw out and show just how that works. It's pretty simple. So if you had like your room, let's draw out like this is the room, and at the top is 0 on the y-axis, and we got room height, and let's just say that's 500, make things easy, and then 0's up here, and then we have our layers here, and let's say lighting was at 100. So if we had like an entity right here at the bottom where their bounding box is flush to the bottom, so their bounding box, say BB, is 500. So that formula was room height, which is 500, minus bounding box bottom, 500, plus 100. That's going to equal 100. So it's going to place this guy is going to be like right up here on this layer. It's actually going to be with the lighting layer, so you might want to actually add more to it, like 101 or 110, whatever. And then in the inverse of that was if we had like an entity up here. Let's just say he's actually flush. You'd probably want to clamp it to keep the player or the object from leaving the room that way. But you know, this will work either way if you do go above it. So in this case, B-box bottom equals 0, and so 500 minus 0 plus 100 is, of course, 600. So down here, it's going to create a positive numbered layer for this guy right here. And the advantage here is now everything's normalized to 0 to room height in a positive way. So it's a lot easier to manage. It doesn't screw up all your other layers. It's just a smarter way to do it instead of depth equals negative y, because you may have seen it's been around forever. Depth equals negative y or negative B-box bottom. This is not great. It's just not thought out. And the difference here is it's not like I'm doing much more. I'm just simply I'm just simply normalizing it to a range that makes more sense to deal with the layers in the room. So, and this also, if we go back here, so if you had other entities, along here, they're all going to be placed in layers that happen within this range, so that it's really easy to manage. Another thing too, when you're normalized from 0 here to 1, another way to normalize it too, maybe we want depth to just be a range from 0 to 1 for other reasons. Like this light engine, that'd be quite useful because it uses 0 to 1 for light depth and shadow depth and stuff. And so that would be even simpler. It would just be B-box bottom. Wow, I can't spell. Bottom divided by room height. So as you can see, room height's 500, so 500 divided by 500, all right, here these two equals 1. And then if B box was 0, 0 divided by anything is 0, so it'd be 0 to 1. So then you'd have like a normalized range from 0 to 1. And it's easier if you don't understand how like why people are always saying normalize something or whatnot. Think of it as a percentage. This is 0% and this is 100%. So that's a normalized a way to think of it. So like in the middle you'd have 0.5 or 50%. So sometimes it helps to think of it a different way when you're like, why is 0 to 1 so special? But in game math and in game programming, you're going to hear 0 to 1 or different ranges like sine and cosine, or they go from -1 to 1. Those are really useful. So having things normalized also makes it so like your system can interact with another system and they can kind of talk a common language. Like I mentioned with the light engine, it deals with 0 to 1 as a normalized range. So if you're dealing in this 0 to room height space and you need to talk to the light engine and say like where exactly is this object located, well, just use the normalized 0 to 1 method, B box bottom divided by room height. So that's it for the tutorial. Hopefully you found that useful. It's a different way to do it than just using -y. In the future, if I have time, I'm going to show how to do it with a shader and the depth buffer, which is the advantage there is your objects all stay on the same layers. You're not creating all these unmanaged layers. Instead, everything's exactly how you had it in the room editor, which is really nice. So hopefully that'll be pretty soon when I can get time to make that tutorial. So anyway, like, subscribe if you have time, and thanks for watching.